Hi, I'm Martin Gilpatrick, and today we're going to talk about a common challenge with serial interconnects when debugging a transceiver-based design. Typically, once a system is assembled, there's really no good way to evaluate the quality of the serial link, making validation a tricky process. I have Louis Bielich with me, who is a Xilinx FAE and works with customers on their designs.
Thanks, Martin. Now, when I'm working with customers' final products, it's very apparent that higher rates don't always give us the luxury of probing a trace for a variety of reasons. But even when you're right under the BGA package, the measurement by the scope doesn't incorporate the work done by a transceiver's equalizer. This is a great example of when you see your probe at higher rates. Notice the eye is closed before equalization from the CTLE and DFE. And notice how wide the eye is after equalization. Martin, can you explain how we can extract the eye scan data?
We've done this with our transceivers by adding what is effectively a second sampler that we can set with the horizontal and vertical offset. Regardless of the incoming data pattern, we can compare the offset sample with the centered sample used to measure the actual data, and then count any differences as bit errors. With the 7 series FPGAs, Xilinx provides the ability to generate a statistical eye scan without requiring special or predetermined patterns, or, most importantly, without interrupting the flow of the received data. And now we're going to show you how this works. This particular system uses Vertex 7 PCI Express Gen 3 plugged into a motherboard with an Intel chipset. In fact, this entire flow is described in Application Note 743, available on Xilinx.com.
The design I'm demoing today is a PCI Express design with the eye scan logic added to the transceivers. Incorporating this logic was very simple since it makes use of the DRP interface of the transceiver, and it only adds about 700 LUTs and 4 block RAM. The design also includes a Northwest Logic DMA and a simple software application to run the data through the system. The software and DMA engine is not needed for the eye scan, but we have it just to show we're running real traffic through the FPGA. Let's begin with the demo. As you can see, we can start the DMA by simply pressing the Start button on the GUI. Now we have approximately 80 gigabit per second of aggregate data going through the system, and we'll continue to have it running while generating an eye scan. To extract the eye scan data, we can source and run a tickle script available in the application note. Because we're measuring at about a bit error rate of 10 to the negative 10, with the full resolution, this should take about 15 minutes to run. Let's kick off the scan and come back once it's done. Now that the scans have completed, let's launch the Vivado Design Suite to get a graphical representation of the scan data. As you can see, there's plenty of margin in the system running real traffic. Though we're showing this in a PCI Express system running at 8 gig, this application note can be used for any 7 series transceiver design at even the highest line rates.
We hope this has been an interesting and useful demonstration of the Xilinx Gen 3 PCI Express hard block and the power that our internal eye scan capabilities can lend to a design. Please visit Xilinx.com for more information on either the application note used today or eye scan functionality.